To another episode of Math Magic with Jen. Today we're going to talk about divisibility tests. There's a lot of them, so I'm doing this one in two parts. Today we're going to be looking at the divisibility tests for 2, 5, 10, 4, and 8. So let's check it out. All right. First up, what the heck is a divisibility test? That's a good question. It's basically a hack or a trick to figure out if a number is divisible by another number without actually doing division. So you can always just do long division, but that's the whole point. Like, that's the opposite of what we're trying to do. We're trying to do like a shortcut hack to see if something's divisible or not by certain numbers. So it turns out that we're going to look at 5 tests today. It's a lot. We're going to look at 2, 5, 10, and then 4 and 8. Okay. So here's an example. It says, can you look at the number 120 and know if it's divisible by 2 or 4 or 5 without actually doing division? Okay. So we're going to start with the easiest of the tests, which is divisible by 2. Okay. So a number is divisible by 2 if the ones digit is even. Technically, it could also be 0. Zero's not technically even, but we're going to throw it on the list. So if the ones digit is a 0, 2, 4, 6, or 8, then we know it's divisible by 2. Okay. So all you have to do to show your work, so this is in 4th grade, by the way, how a 4th grader would show their work is by underlining or circling the ones digit and then doing a yes or a no. So for example, when I look at the number 358, the 3 and the 5 don't matter. All we care about is that ones digit of 8. And 8 is even. So the answer is yes. This would be divisible by 2. Okay. On the flip side, down here, if we have the number 2,407, we don't care about the 2, 4, the 0. We only care about the ones digit. And that is odd. This is not even. So that's a nope. And that's all the work you have to show. That's it. Just underline, highlight, circle the ones digit, and you're looking to see if it's even. Yes. If it's odd, no. Okay. So that was the easiest test. The next set of tests are actually pretty easy too. So this is the divisibility test for 5 and 10. So it's 2 separate tests. A number is divisible by 5 if the ones digit is a 5 or a 0, right? If you count by 5s, 5, 10, 15, 20, 25, it's either a 5 or a 0 for that ones digit. A number is divisible by 10 if the ones digit is a 0. So again, counting by 10s, 10, 20, 30, 40, 50, all those have a 0. So here, all we're going to do is we're just going to look at the ones digit. If it's a 5 or a 0, it's divisible by 5. If it's just a 0 for that ones digit, it's divisible by 10. So here it says circle the numbers that are divisible by 5. Put a star by the numbers that are also divisible by 10. Well, let's go look at 5 first. Okay, so this first one has a ones digit of 5. So that's a yes. So this is yes divisible by 5. The ones digit is a 0. So that's a yes divisible by 5. The ones digit is a 3. That's a nope, not going to work. Over here, 710, the ones digit is a 0. So that's a yes. And man, we got lots of yeses on this one. 995, that ones digit is a 5. So we've got 4 yeses and 1 no. So all of the ones I've circled are divisible by 5. Okay. Now we want to know of these, which ones are also divisible by 0 or by 10. So I almost gave it away. We're looking for a ones digit of 0. So this one is not divisible by 10. This one has a 0, so that's a yes. This one's already a no. Nope. The 0, yes. And then this one is a no again. Okay, so again, what I'm looking for is either to have that ones digit be a 5 or a 0 to have it divisible by 5, and a ones digit of 0 to be divisible by 10. Okay. Whew. All right, so then it says, can you make up a 6-digit number that is divisible by 5, but not by 10? Okay. Well, to be divisible by 5, we need a 5 or a 0 in that ones digit. But if we don't want it to be divisible by 10, then we don't want a 0. So that means that our only choice is to have a 5 in the ones digit. Okay. What do we write in the other 5 spots? Anything you want. You could write 7, 7, 7, 7, 7. Yep. Sure. You could go, oops, 9, 8, 7, 6, 4, and then 5. All we really care about is that that last digit's a 5. You could also just do, a string of 5s. The main thing is that that one digit needs to be a 5. Okay. All right. Now I went through those tests for divisible by 2, 5, and 10 pretty fast because you probably already knew these. When you think about counting by 5s or counting by 10s, it's just kind of an aha moment of, oh yeah, that's true about those kinds of things. Now we're going to slow it down just a little bit to get to the next divisibility test, which is 4. This one I actually did not know until I taught this class. Like I had no idea about the divisibility test for 4. Um, Mainly because I just don't think it's commonly known, maybe. I mean, I don't know. I mean, I do have a master's in math, but whatever. Okay, so here we go. A number is divisible by 4 if the last 2 digits are divisible by 4. So we're not just looking at the ones digit, we're going to look at the last 2 digits. Okay. All right, excellent. So if we were given this problem, for example, that is 1,144, the 1,100 doesn't matter. The thousands and hundreds place doesn't matter. We only care about the last 2 digits. So 44 is divisible by 4, right? 44 divided by 4 is the number 11, right? So it turns out, this is the weird thing, that if the last 2 digits are divisible by 4, then the whole thing is. Weird, right? Okay. You want, you can prove it to yourself just by actually doing the division. Like this is the opposite of the divisibility test is to actually do the division, but you will end up getting a remainder of 0. What the heck? We'll go for it. Goes in twice for 8. Goes in 8 times for 32. And then 6 times for 24. And yep. Okay. Why does it work? It's actually not an easy proof. So they're not going to have you prove this to your 4th graders. What I would say is you could have them prove it to themselves by checking the long division. And then hopefully they believe it. They're like, whoa, it works. It always works. Okay. All right. So if we're going to keep going with this divisibility test, you'll notice that if we flip the digits, 4,411, I just want to focus on the last 2 digits, which are 11. 11 is not divisible by 4. Okay. So when I say isn't divisible by 4, I mean like, hey, if I divided by 11 by 4, I'd get a remainder that's not 0. You could also think of it as a multiplication fact of 4 or a times table fact. Okay. So it says here, create a 4-digit number that is divisible by 4. Okay, awesome. And it says, but it must begin with the numbers 55. Okay. So I just have 2 more digits to come up with. It can be anything as long as those 2 numbers are a multiple of 4, okay, or are divisible by 4. So you could go easy. You could go 0, 4. That would work. You could go slightly more exciting and write a 12 in there. 12 divided by 4 is 3. How about 32? Because 32 divided by 4 is 8. Okay. So there are so many different choices. Let me give you one that fails, right? 5502. O2 is not divisible by 4. So that was a fail. Okay. Oh, trust me, I understand some of you right now are going, really? This is the test? It is. And I will say the hard part about this particular test is that you just kind of have to believe it and you can't really prove it other than proving it by example. So, what I mean by proving it by example is you could have students do long division to show, in fact, 5,512 is divisible by 4. As a check that yes, the last two digits does work. And if you have two digits that aren't, so like this one, if you have the last two digits aren't divisible by 4, then you could show that it's not going to work, that I'm going to get a remainder of something. Okay. Now, I will say, I started off the divisibility test for 4. I was kind of surprised they included this in the Common Core textbook. They included this one, and they also included divisibility test for 8, which is the next slide. So I don't know how they chose these two in particular, but we're gonna do it too. Okay, this is my least favorite test. I know, I gotta be honest. Here's why. So I'm not gonna hide anything from you guys. A number is divisible by 8. Sorry for the wiggliness. If the last three digits are divisible by 8. Last three digits. Okay. So, for example, 1800, 1800 is divisible by 8 because the last three digits is 800. And 800 divided by 8 is a whole number with a remainder of 0. So that's what I mean by divisible, is I get a remainder of 0. Okay. Want another example? How about 9,040? 040 are the last three digits. That's the same thing as the number 40. And yeah, 40 divided by 8 is 5. Okay. Another one, I could just make up another one right now. 7,888. So again, these last three digits, hopefully you guys agree that 888 is divisible by 8. Okay. So if you're wondering why am I not the biggest fan of this test is not that useful unless the last three digits are easily divisible by 8. So what I'm saying is 800 was easy to see. 40 was easy to see. 888 is easy to see. But if you gave me this number, 1,368, it's not obvious to me if 368 is divisible by 8. Like, I have no idea. Like, I'm good at arithmetic, but off the top of my head, no, I don't know if that's divisible by 8. So to me, this really isn't that much of a hack for things that aren't obvious. Okay, so what would we do in this case? In this case, I'd be dividing 368 by 8. It goes in 4 times. And then 8 goes into 48, 6. So apparently this is a yes. This actually is a yes. So yes, it worked. But again, I had to do long division to show that. That's like the opposite of the hack. The hack is supposed to save us time. That did not save me that much time. Okay, so what does this mean then moving forward for this divisibility test for 8? Well, what I'll say is I would focus as a teacher on numbers that were obviously multiples of 8 for those last three digits. So like the last three digits, it could be any sort of multiplication fact from our times table, and you could have a 0 in there. So like 064, right? I already did earlier 880. You could even do like a 080. And again, I would think that these should be obvious. It's kind of scary to use that word, but hopefully those look like a multiplication fact. Okay. Whereas if you asked me this one of 120, I have no idea if 120 is divisible by 8. Like, I'd actually have to do long division to see if those numbers actually work. So that's what I'm trying to show you is that for some problems, it's a cool hack. For others, it's really not saving me a whole heck of a lot of time. Okay. So, how am I going to ask you to do some problems? Well, I might do something like this. Can you create a 5-digit number that's divisible by 8? Sure. What if we just did all eights? I mean, yeah, right? Okay. If you didn't want to be that kind of crazy, what if we kept that 064 as the last 3 digits and then maybe I did the first two as 33? So I'm just saying you could technically make up any numbers you want for the first 2 digits as long as the last three are something that is divisible by 8. Whoa, that was it. Okay. So you want to make sure you review the divisibility tests, that's a mouthful, for 2, 5, and 10. Those look at the ones digit. 4, which looks at the last 2 digits, and then 8, which looks at the last 3. Our next video is going to be part 2 of divisibility test, and we're going to look at 3, 6, and 9. So I hope you enjoyed this one. Maybe you learned something new today, and have fun practicing math, and hopefully I'll catch you on the next video. Bye-bye.